Polynomial division is the topic for today. There are two ways of doing polynomial division. You can do a process that's long division that mimics the same long division you learned how to do with numbers back in elementary school. Works exactly the same way. But there's another way of dividing polynomials called synthetic division, which only works in a special case. So just to remind you that when you're doing a division problem, this could have started off as the fraction 427 divided by 35. So your numerator becomes what's called the dividend in the long division. Your denominator becomes the divisor. Then you go through the process of doing the division algorithm. It's probably been a while since you've done this, but just to remind you the way that the process, kicks in, it's something like this. You say 35 goes into 42 once. 1 times 35 is 35. Subtract that from the 42 up above it, leaves you with 7. Bring down the 7, and then you start all over. 35 goes into 77 twice. 2 times 35 is 70. Subtract that, you get 7, and then you're done. Because we're not going to deal with decimal calculations in polynomial division. We're actually going to state our answers the way this would be as a mixed number. When you finish, you got a quotient of 12, a remainder of 7. The proper way to state your answer is quotient plus remainder over divisor. Quotient plus remainder over divisor. Now, that simplifies, in this case, quotient's 12, remainder over divisor reduces to 1/5. So in this example, you would have 12 and 1/5 written as a mixed number as your answer. It works the exact same way with polynomial long division. So in my first example here, I want us to divide this quadratic polynomial by this linear one. Okay? So this is my dividend, this is my divisor, and it looks exactly the same way that you set up numerical long division. Put your divisor out in the front, 3x minus 2, open up a division bar, and then put your dividend inside, 12x squared plus x minus 4, and then the division process starts, okay? Now you're probably going to need to watch this video a couple of times if you're new to doing long division, or even synthetic division that I'll show you here in a little bit, just because it does mimic the numerical version perfectly, but you just got to be really careful about where you build your quotient from. So what you do is you actually compare the first term in your divisor, the 3x, to just the first term in your dividend, and ask yourself, what do I need to multiply this 3x by to make it become 12x squared? In other words, how many times does 3x go into 12x squared? Well, that would give you a coefficient of 4 along with 1 extra x. So since the first part of my quotient is 4x, you're going to need to put that above the x column on top of the division bar. Okay? So every space value in the polynomial contributes a very important column into the division process. Same thing here. Every space value here is represented on powers of, multiples of 100 and tens and units. So just like the column spacing here is very important, the column spacing here is very important. Make sure there is a column devoted to every possible power of x that could be in your dividend. And line them up based on the quotient being an x term. It's going to go above the x term in the dividend. So I've got the first part of my quotient listed there. Now I want to take that and multiply it by both parts of the divisor. 4x times 3x is going to give me 12x squared. 4x times negative 2 is going to give me negative 8x. Okay, then you pause for a second. At this point, in numerical long division, you subtract that new value that you got from the two place values up above it. You're going to do the exact same thing here. But we haven't done our subtraction sign change yet. So you need to change this one to a minus, change this one to a plus, change all the signs across that polynomial to guarantee you're subtracting them correctly. So 12x squared minus 12x squared is 0. This should always be 0 if you've set it up correctly. X plus 8x, you've already changed that sign, So subtracting negative 8 is adding positive 8x. Those should add up to a 9x. And then, just like up here, you're at the point where you bring down the 7. Now we're at the point where we bring down that negative 4. And the process starts all over again. You want to compare the first term in your divisor to this first term right here. 3x times what gives me 9x? Well, that guarantees the next part of your quotient is going to be a plus 3. Now you take the 3, multiply it by both terms of the divisor. 3 times 3x is 9x. 3 times negative 2 is negative 6. I want to subtract these from the ones up above them, so make a sign change all the way across. Negative 9x and then positive 6x, or positive 6. So I've already accommodated my sign changes. These should cross out to 0 like they always do. Negative 4 and positive 6 makes positive 2. So now I'm ready to format my answer. The answer should be quotient. So the quotient is 4x plus 3 from the top of your division bar plus remainder over original divisor, 3x minus 2. And you've achieved the goal of the problem. You've done the division, the long division of those two polynomials, and that's what the division turns out to give you. It gives you a linear polynomial with this rational expression. Okay? Let me show you one more example of long division. Okay? With a little bit of a warning. Well, this isn't so much a warning, but whenever you reach a zero remainder, then the divisor you're checking actually turns out to be a factor of the dividend. Okay? Another thing, here's the actual warning. If there are any missing terms in your divisor or your dividend, either one of them, then you need to put deliberate zeros in the place of those missing terms. So let me show you what I mean. Here I'm dividing by x minus 5. So my divisor goes on the outside, x minus 5. Open up my division bar. Now, I'm dividing it into, this is my dividend. It leads off with x cubed. Now, you're missing the x squared term, and you're missing the x term. You have got to put deliberate zeros in the spacing of these terms. See, when this happens with numerical long division, we just put 0 in the hundreds unit or 0 in the tens unit, and they're filled in there automatically. You're not in the habit of doing that with polynomials like this. So you need to put a deliberate 0 coefficient for the x squared term that's missing, and a deliberate 0 for the x term that's missing, and then you finally are down to the negative 125 that's on the end. So see, a degree 3 polynomial can have at most 4 terms on it, and if there's any terms missing, you need to make sure you put the deliberate zeros in those spaces. So now the division algorithm is ready to start. X times what takes me to x cubed? I need to multiply x by x squared to get to that x cubed, so that's the first part of my quotient, is x squared. X squared now multiplies by these two terms in the divisor. X squared times x is x cubed. X squared times negative 5 is minus 5x squared. You're subtracting, so don't forget the sign change you need to do here. And don't forget that this has a coefficient of 0. So this minus this is going to be 0. This is technically 0 plus 5x squared, keeping that 5x squared value. Now your next term you bring down is just the 0x. And the division starts all over again. X goes into 5x squared, 5x times. So since the next part of my quotient is x, I'm going to put it above the x column. 5x distributes to those two to give me 5x squared minus 25x. Change my signs to accommodate the subtraction, so that those can cancel out to 0 like you want. These add up to 25x. And then finally bring down that last term of negative 125. And the last of our division kicks in. X can go into 25x. 25 times, and then 25 times x is 25x. 25 times negative 5 is negative 125. So in this case, when I do the subtraction, they both cancel out, and you're left with a 0 remainder. Well, when a 0 remainder is obtained, then the divisor you're checking is actually a factor of the dividend. So in other words, we just factored this. This is our quotient. So our answer is x squared plus 5x plus 25. But what this technically means is this is kind of like an advanced factoring technique. We just factored out x minus 5 from this polynomial as my dividend. When this factors out with a 0 remainder, that's what's left over. So this technically means x cubed minus 125 can factor as the x minus 5 we divided out, and the other factor left over is your quotient, x squared plus 5x plus 25. But the only time that's reliable is when you get a 0 remainder. 0 remainder means you just found an actual factor. Okay. All right, coming up next is the other division algorithm I've got to show you, which is synthetic division.